So I'm Elizabeth. I work at Airbnb. I'm on the search. Oh, hey, cool. Thanks, Muriel.
There you are.
Uh, I'm I'm on the search and knowledge infrastructure team at Airbnb. So and so when I make deploys at work right now, I'm partnering with an SRE on the team, or I'm running the pipelines. When I'm at home or in previous roles, I've deployed to GCP or onto my own what are they called? What are the little ones? Raspberry Pis. I have my own Raspberry Pi Kubernetes cluster server farm at home, so I like to play around with that. But so at work, AWS, GCP, and then I deploy with my SREs. And I am based here in Portland. So we have a Portland office. If you didn't know, we're pretty small. We used to be big, or the office was big prior to the pandemic, yada, yada. Now we have a small office. And I I joined Airbnb in 2017. I joined in the customer support org. So I was answering calls from hosts and guests. And so you might have talked to me back in the day if you ever had any kind of issue finding a key or under the mat somewhere. And I was introduced to coding at work. Some engineers taught an intro to web dev class at lunchtime, and I was like, well, I guess I should take that kind of like a CPR class. Hopefully no one will ask me to do that. It turns out it was really fun and interesting, and I liked it. So I went back to school and I transitioned to engineering at Airbnb in 2021. And like I said, I'm on the search backend team. That's me with my torch that I was telling you about. Last summer, I ran with the torch at the Paralympics in France. Airbnb is a sponsor, and so I went. Oh, and importantly to know that all the opinions here are mine. They're not Airbnb's. It's just for me. Yes, yes. In red down here. And Muriel, my friend, is joining us all the way from Long Beach.
Hello. And so I'm up in Playa Vista at the moment in the office, which is just a little bit north of LAX. So somewhere here in the SoCal. And hopefully my voice volume isn't like booming over some loudspeakers and like, at a 11 or 12. Tell me and I can tune and adjust or speak louder if I need to. But this is me. Same. I've been here at Google Cloud for 5 years now. But like Elizabeth, this talk is kind of a brainchild of some ideas that we had kicked together. So speaking on my own behalf. But as far as deployment goes, before I started here, I was working in DevOps by way of systems administration and tech support and cloud and release engineering for some time. So I've deployed a little bit of everything to everywhere, from data center to bare metal. I have a small stack of Nux at home as well. Um, but while primarily have been working to help our enterprise customers, that's sort of where I work here, is helping customers be able to build, deploy solutions on cloud. I have worked with Amazon before. I have also done stuff with Azure, and of course love the GCP world. And working in the DevOps space, I've mostly on the Java side have supported teams that have been working with Java and have maybe written a line or two. But I'd love to hear feedback from all of you, as y'all are the experts. So anything in that world we'll touch on a little bit. It's mostly been limited to helping folks like chase down OOM errors and figure out why things crash because memory got capped or something. So it's great to be here with you all. Thank you, Elizabeth and Biju, for the invitation. So this, I think, should be a super fun event, and we'd love to keep it interactive. So I don't know, are we ready to launch on forward? All right, so today's main focus will be deploying containerized applications to Kubernetes. So we're specifically in the world of CI/CD and deployment and all of the different ways that we can take an application from code to running live. We'll focus on this little subsection, going through just some core stuff, fundamentals, and then also looking at a round of different tools that are out there and available. So I think I'm actually not sure if what our timeline is, if it's still 45 minutes, but essentially we'll go through some basics, fundamentals of CI/CD, take a look at some different open source tools that are out there in the ecosystem, look at how to be able to make decisions around the tools that you want to use, and then we will also go into a bit of a deployment demo. And back over to you, Elizabeth.
Awesome. And for anyone who's totally not sure what Muriel just said on that last slide, like, don't worry, hang in there. We're all together. Don't panic. This is a beginner-friendly talk, so no previous knowledge is really necessary to how the tools that we're going to be talking about and the concepts that we'll be covering. It's very, very beginner-friendly. And I know we all did intros, but let's do a quick survey with some clapping because it's late in the evening. So if you feel like you are a beginner with deploying, clap a little bit, just like a little bit. Yeah. Okay. And if you feel like you're pretty comfortable, you could do this at work if somebody asked you to. A little bit louder. A little bit louder. Okay. Hey, that's much louder than I was expecting. Okay. And then, like, do we have any real experts? People who feel like I do this in my sleep. Anybody? Yeah. Give it up. Give it up. All right. We have an expert. Anyways, yes. Thanks everybody. And like, love to feel the clapping. Love to get everybody involved. And let's talk about our demo app. So, linked in the slides, which I'm not sure how we'll get out to you, but if you want access, this is our demo. We have a demo repo that's filled with code to help you get started. You can try deploying some of, we have like a sample app that we forked, and there's some different deployment options and tools that you'll see in the app, and it'll include all the materials that we cover in the talk. And it's a work in progress, so like keep in mind, it's open source, and it provides examples from all the different tools that we'll be talking about. And yeah, go ahead, Muriel.
Sure. I'll add another note too about the demo app. It is built in Python for those bilingual or multilingual folks. Eventually it may be a project to port it over to Java, but one thing we can do is share out after the fact some other samples. So there are a few labs out there that look at using Spring Boot to deploy to Kubernetes and go through some of the different tools in the ecosystem so that you can kind of cross-platform and cross-language using some of the same approaches and concepts and so on. When we're looking here at the world of DevOps, development and operations, essentially this is like creating this harmony, right, between your developer and your operations teams. So there are kind of two components to this, and many of you have likely seen this infinity symbol of the DevOps world, where you've got kind of these two divisions of one, your inner loop of development, and generally that's stuff that is happening on your kind of like development workflow. So that's things that might be happening in your IDE, everything from your coding, your local building, and your testing. So things that you would do just as you're in your day-to-day development, heads down, getting some code knocked out. The outer loop then starts to look at everything from that code is now ready to be able to get deployed and run in a staging and a production or even a testing environment. And so that outer loop is basically taking any of that code that has then been saved or committed to a repo and now being able to do the deployment, release, any of the operations around that. Monitoring will be a portion of that. So essentially, it's this iterative process of getting the things that are happening locally within the development or software engineering team all the way through the operation side of being able to run something in production. And this kind of happens over and over in the software development application lifecycle. So just a little snapshot of a few small tools that are available in the ecosystem. As you can see, there are quite a few across the entire ecosystem. And all of these tools are continually kind of being updated. There are new things that are coming out all the time. And also as a practice and as a principle, like DevOps is really seen as this philosophy around software development. There are a lot of different like roles or implementations, and it's just kind of an evolution of a lot of the same core concepts about being able to get your code running in production. So you might see release engineering or platform engineering, and there are so many things to look at in this world, everywhere from, where are you going to host, which we talked a little bit about, where are you storing your code in version control, what kind of dependencies are out there. So there's a lot to be able to consider, but going back to sort of our original premise, we're really going to try to stay streamlined today and focus on being able to deploy that containerized application into Kubernetes. So, love to hear maybe after the talk if there are some favorite tools that we didn't mention. As another note too, we are going to be focusing on open source stuff. So I know things like GitHub Actions and other things out in the world are pretty popular, but we wanted to make sure we had that open source focus today. So looking at a very basic deployment process, you have your code, and this might live somewhere like your IDE. Here is shown as Visual Studio Code, or maybe folks are using IntelliJ, or whatever your IDE is of choice. Then that code will then get hopefully saved into a version control repo. There is going to be some build and deploy process. And here's where I pretend that I know things that are happening in the Java world and say that there are tools out there like Ant or Maven or Gradle that can be used to build your code or package it up in some way. And then from there, it gets sent over into your system. So that might be the NUC, that might be in the cloud or whatever. And there may be some automation that happens along with that. There may be some manual processes where a human is very engaged in having to do that build and then deliver to the eventual server. And so this is just sort of not even looking at the container world, what your basic deployment looks like. So when it now comes to the Kubernetes world, there are a few layers of complexity that get added on top of that. So you still have your application code, but from there, typically you would have in your repository something like a Docker file or other tools that are able to help you turn that application itself into a container image. There are also some tools out there, such as like build packs or Jib, that can take code that exists and be able to kind of see and analyze and create that container spec for you as well. But essentially what needs to happen is that code, before it can go into your Kubernetes cluster, has to somewhere get built into a container image. So there will be some build steps along the way. And then from there, that image, once it's built, then lives in your artifact storage. And so that artifact repository essentially will host these artifacts like your container images, your Helm charts. We'll be talking about Helm a little bit later, and so on. From there, you may have this other step where these application configs that are typically going to be in YAML format and kind of define the state of the application, the image that's going to be pulled, and so on, will be stored possibly in the same repo, maybe in a different repository. And then from there, after the whole build process is complete, then the deployment will happen to now send that image over into your Kubernetes cluster. One of the great parts of that, of course, in the container world is that now, because you have that isolated container image, dependency management becomes a much simpler task to be able to have and manage doing things across different versions. So there are, at the bottom, you can see two approaches to the deployments. One is when you look at the push-based method, which is generally imperative, which means that you are saying you are basically running a command against the cluster or running a series of steps that define the current state or push your application out. What the more preferred approach is using this pull-based method, which is essentially generally declarative, which means that somewhere you declare or document, typically in version control, what the state of that application is going to be in the cluster. And there's this reconciliation to say, this is our source of truth. This is what the application should look like. And the Kubernetes cluster will essentially reconcile and say, okay, I'm going to make sure the application matches the state that is defined. And so that really helps because it is kind of duplicatable. You're going to have a source of truth. And it's really taking that like kind of Kubernetes model in mind. So from here, I will pass over to Elizabeth. One more time. There you go.
Thank you. Great intro about all those different or like the high level overview there. And what we're going to talk about in this talk are some different tools that you could incorporate into your CI/CD workflow. And so we'll cover developer workflows, some templating, packaging, configuration, management tools, and then 4 different CI/CD tools. So why are there so many different types? Why are there so many tools? I have an analogy that I like to use. So consider this: you're getting dressed for your first day of work at your new job. So first you pick an outfit. Just pick it, and maybe that's your dev environment. And then you might ask your friends what they think about your outfit. That's version control, let's say. And you probably want to try it on. We'll call that staging. And then you wear it out, and then you go into prod. You push that straight into prod, right? So there's a process that works there, but consider what if your job is an ambassador at the UN? Okay, the stakes are different. You're not just walking in to casual Friday at the office, people in athleisure wear. You're going someplace where like there's heads of state, people of your country depend on you, and it matters what you wear, or there's just other things to consider there. So in addition to those previous steps, you'd probably want to check, add some other steps in that process along the way, like check the weather. Okay, you could check the weather. That we'll call that a developer workflow. You probably want to Google what the dress code is. Maybe there's something that you have to be wearing and you don't want to show up unprepared. We'll call that a developer workflow tool. You could bring a backup sweater, and that's not fancy. It just could be cold. And thank you. I heard a laugh. That's my big joke. And you'd also, you're taking into consideration that there's a process to be followed, and depending on the outcomes will be different, and it matters. So you want to be able to scale that, change it to the different environments that you're in. So and all of these tools have in common that they help developers get their code into production. So yeah, we'll get into some of these tools starting now. And first, let's take a look at examples of a manual deploy.
All right. So thank you, Elizabeth. This is kind of that imperative manual deployment. So here and throughout the demo, we're going to make assumptions that you have a working cluster to be able to deploy to that has all of the credentials already available, so that kubectl, which will be the main command that we're looking at for the next couple, is able to access the cluster. And that might be something that's running locally, such as Minikube, or maybe something that's on a NUC or Raspberry Pi, or your various clouds of choice. So from here, if we're looking at this YAML, which is going to be kind of our currency of choice for a lot of the Kubernetes deployments, essentially what we're doing is passing in this output directly into the kubectl create command. And what we're doing is we're reading this in as a file and telling kubectl in this sort of imperative command-based way to be able to create this deployment. So we're going to be deploying based off of this image, and you can see there's the image definition from that artifact repository that we mentioned. that's now going to get sent over to the server. So one note is that when using the kubectl create command, essentially that is the thing that you are able to do is create. So if you try to run this again, then it will fail because it will say, well, you've already created this object, so you will not be able to create another one. So this is just kind of a straight manual deployment. Say you've got a snippet of code that you found somewhere with a sample deployment that you want to just send right in, but you can also save that into a file and run the same thing against a specific file. And that's what the -f flag is for. So here are a couple other methods of being able to do manual deployment using kubectl. And so starting to move over into from declarative into a more declarative format is if you're running kubectl apply versus create, essentially that state will be matched. So if you have that YAML file, or you can have an entire directory with a set of files, then and you run that apply, if those objects already exist, then it will do nothing. If the objects are not present, then it will actually create those deployments and those applications. If there are changes, then those changes will be applied. So it's kind of one of those things where you're now being able to reconcile the state based off of what is defined in that set of files. A third way of being able to deploy an application is actually through kubectl run. And what you see at the bottom is just sort of this also imperative approach of running an image directly. And here you can see that that path to the image is actually being passed directly in. The one thing about that is what's happening is a pod is being created versus a deployment or a different type of object. So essentially, if that pod is deleted or removed, then it's gone. Versus if you have a deployment, for example, with multiple pods, then if one gets removed, then the state will try to be brought back up to match whatever was defined in that deployment. So those were three methods of just being able to use the kubectl command directly to do a deployment, create, apply, and run. And I will, oh, this is still me. I was going to pass over back to you. So another tool, looking at some different tools, is Scaffold. And Scaffold is essentially this open source tool that helps to really work with that inner loop and streamlines the development workflow. So it's a completely client-side tool. Some of the definitions for this tool will live inside often that actual repository where you have the rest of your code. And what it does is it kind of simplifies that dev process that we looked at earlier, because essentially, when you're going through that, source to deployment, you might have several things. So there may be your initial packaging that you're doing with your Maven or Gradle or whatever, and then you have to do an additional build, either using Docker or using the other build tools if there are native image build capabilities. There's tagging, pushing, maybe creating those Kubernetes YAML manifests, applying those, and then viewing the logs. So essentially what Scaffold does is creates a definition for your environment and your dev tools so that now you can run a series of commands, like for example, Scaffold dev. What that will do is it will take that definition and say, well, this is the way that I want my local dev environment to run, like run locally, maybe use this type of build image, and it will do all of those steps in the background so that a developer that's coming in to be able to start working on a code base can basically get started much faster without having to necessarily have the awareness or the need to go through those additional steps. Basically, it's like, all right, we just want to get people enabled to be able to start, be up and running right away. So essentially, just to summarize, it's this developer workflow tool that basically takes care of defining a lot of the build and package stuff so that, the dev process can start a lot faster.
Awesome. And thank you, Muriel. We have a couple of configuration management tools to look at next. So first up is Customize. And it's really weird to giving this talk. We've given this talk a couple times. We presented it at KubeCon last year and then at Scale earlier this year. So seated. Okay, great. So Customize is a configuration management tool that provides your solution for customizing your Kubernetes resources without using templates. So simplifies your Kubernetes configuration management by it uses a base and an overlay system. So it makes it easy to manage the different environments like dev, staging, and production. You can generate your resources like config maps uh, and secrets directly, which is handy for storing configuration data. And finally, it's great for combining and customizing your different resources and keeping them organized and flexible. So to note, check the docs on your kubectl version because sometimes it's bundled in, sometimes it's different. So just make sure you double check. Oh, thank you, Muriel. Next slide. This is also the first time we've done this not in the same room. So thanks, everybody. Uh, so, so again, the key concept with customize is layering. So we have a base, which will define our common settings, and developers will use overlays to make changes to that base for specific environments. And then we add patches where we can make changes without touching the original configurations. So let's take a look at an example from our demo repo. Thank you, Muriel. So this is an example that's in our demo app. So what you'll see here is a snippet from the file structure in the demo. So I have big green letters. And you'll see that in the Pete's directory here, you'll see the directory customization file, boop, boop. So that's over there on the side, and the arrows pointing to the resources that are declared in that file. So deployment, service, config map. And then the second concept we're talking about is the overlay. So we use the overlays to manage a configuration variant, like staging or development or production, where we modify our common base. So you can see that in the red, it references resources. So that's the resources file up there. And then the patches are where we directly make changes without touching the base layer. So make sure I read my notes. The overlay, again, is just another customization file that references the base and defines the changes that we want to make. So this configuration makes it really easy to modify or see in Git. And we can see in this example that all the resources are written out exactly or as references, no templating. And so let's take a step back. Remember, this is a beginner talk. So let's take a step back and talk about templating. Why is that a benefit to any of us? So, or why do we want that? A templating pattern in the context of Kubernetes and YAML refers to this method of creating a reusable and customizable configuration file for your Kubernetes resources. And it allows developers to manage your complex almost more efficiently by reducing repetition in your code and enabling dynamic generation of your Kubernetes manifests. So customization like feature is that it doesn't use any templating. And why would an engineer like that? Because you can see exactly what's defined in your base and your overlays. And the next tool that we'll look at is Helm, which uses templating really extensively. And some teams love to use that. And why? Because you don't have to manage all the files exactly in Git. Like it auto dynamically changes for you. So there's advantages to both approaches. So let's take a look at Helm next. Back to you, Muriel.
Awesome. So moving on to Helm. Helm is essentially the package manager for Kubernetes. So it's similar to package managers like apt or yum or homebrew if you're on a Mac, or NuGet or other things that basically can take and define these applications. But Helm specifically helps to manage these Kubernetes applications. So it's been around for some time, since 2015. But here we're specifically going to be talking about Helm 3. Helm 2, which was the previous version, actually had a server-side component and a client-side, but this current one is now just specifically on sort of the client side. And so essentially in defining and managing these applications, you can create what's known as a Helm chart to define and help you install and upgrade your applications. And it takes care of a lot of the dependency management as well. So if you do have an app that has multiple components, maybe there's a data layer, a storage layer, there are some other pieces, like say for a stateful app, for example, that have requirements beyond just a single deployment. Helm is great because it can define and pull all of these things together. So that's one thing that's really convenient about that, is that it's great for more complex deployments. As another note too, which I don't remember, we might have mentioned, is one key difference as well between Helm and Customize is that Helm, that Customize is actually natively integrated with kubectl, so you can run kubectl and then point that into some of your Customize configurations or files, but it doesn't really do package management. So using these two together, Helm, as mentioned by Elizabeth, does take that templating approach. So you can actually use Helm and Customize together to be able to do your deployments as well. So let's look at charts. So essentially, a Helm chart is a collection of these files that define different resources. So it may be everything from the deployment itself, which will be your core application. Maybe there's a config map that has a set of different configurations or variables. You might have your service account, the service definition, and so on. So it's really convenient because these can be versioned, published, saved in an artifact repository out there. And essentially within that chart, you'll have the actual, like as I mentioned, the manifest, the templates, and then these values. So for example, if you wanted to have an application that had different configurations for your development, your staging, and your production environment, those can be defined using these different environments within your values. So you just have the same set of files where the templates are now going to just accept injected values. So it's very useful because if you need to look for an application, say you need a WordPress app or you need, whatever else it might be, then essentially you can go out there and look for something that might already exist. So just some basics around the commands, and we'll look at this when we go into demo. Helm, there is a command line tool to be able to manage Helm. You can install that with your package manager of choice. So there's a lot of, back and forth in package management world. There is an integrated hub, which actually is kind of like similar to Docker Hub. It's Artifact Hub, which already has quite a few different applications that you can pull and reference and sort of run out of the box. And you can also add your own custom repos or any one of the other published or publicly available repos that are out there in the wild. To be able to install to your cluster using Helm, you can actually use Helm install from the command line. And what that will do is just kind of rely on your Kubernetes credentials that you've been using previously with kubectl to now install that application directly onto your cluster. And you can do some lifecycle management with that as well. And I think from here, we are going to pass on to Elizabeth.
Yes, we're getting into the CI/CD tools, pipelines portion of the tool coverage. So let's talk about what is a pipeline to get started. So a pipeline is a set of tasks that's executed in a defined order. So you'll see it's a structured automated process. It facilitates the rapid and reliable delivery of your software from development to production. And a pipeline has built-in support that'll help you identify common issues that might come up in your build, test, deploy. Sometimes you'll get a little notification. Sometimes you get a Slack integration. I don't know, however your work has it set up. And they can have parallel and conditional execution. They create an audit trail. So you can see in the code or like in your YAML, you can see, however yours is, you can see it, like, oh, these are the steps that are going to be taken. I know exactly what's coming up or what has happened. And they generally cover all five or your 5 stages of source control, build, test, staging, and finally deploying. Okay. Um, we have 4 different tools now to cover. Talked about our pipelines, Jenkins, everybody's favorites. All right. Give a big salute to good old Jenkins. Raise your hand if you've ever used Jenkins. Yeah, okay, that's mostly everybody. And we start here because we should start with Jenkins. It launched in 2004, which predates Kubernetes by like 10 years. And so most people have worked with it, used it, looked at it, and might still use it today. What does it do? It is used to automate those various aspects of your software development lifecycle, including building your pipelines. So it supports why Jenkins? What are some key features? It has hundreds of plugins and allows integration with virtually any tool in your CI/CD tool chain. It's a self-contained Java-based program that runs on Windows. Thank you for laughing. Windows, Linux, Mac OS, and other Unix-like operating systems. It has a web interface. You can see your error checks that come up. And it can distribute your work across multiple machines, so that will enable your faster builds, test deployments across your various platforms. And taking a look at a pipeline here. So there are 2 styles of Jenkins pipelines. There's scripted and declarative, and both serve the same purpose, but cater to different needs. So scripted pipelines better suited for more complex workflows requiring detailed control and customization. And declarative pipelines are a newer feature that people like their simplicity, readability, ease of maintenance, standardized CI/CD processes. And for many projects, people like to combine them both. That's kind of a theme in most of our tools. It's like, oh, you use these together, or, but for a lot of projects combining both of those 2 styles, there's an option to use an embedded script block, which can offer the best of both of those worlds. So here's an example of a Jenkins declarative pipeline. And it doesn't look like YAML because it's not. We've looked at a lot of YAML tonight. That's not YAML. That's Groovy. Give it up. Give it up. We said Groovy. That's good. That's good. Okay, we'll take a look at our next tool, Tecton. So Tecton launched in, well, do I have it up there? Oh, I know it was 2019 in the Continuous Delivery Foundation. That's what I know. But it originated as the build system for the Knative serverless workload platform. Tecton runs as an extension on your clusters. It provides a set of reusable components for creating your pipelines. So you create and run tasks in YAML, and you can manage your runs using its CLI TKN. It also has a GUI dashboard. Let's take a look at some key concepts, key components here. So the step is the most basic unit. A task is a collection of ordered steps, useful for simpler workloads like running a test or linting. A single task executes a single Kubernetes pod and uses a single disk, and generally just keeps things pretty simple. A pipeline is a collection of tasks. And there's also the concept of triggers, event-based. We won't cover, just wanted to mention it. It's interesting. And I'll show in some code here a walkthrough of what setting up a task looks like. Let's see. Okay, Tecton, set up a task run. Great. So let's use a step and a task. The task, task, you can see it up on the right. It's red. It's kind of, sorry, it's kind of small in this setup, but is represented in the API as an object kind task. And it defines a series of steps, which you'll see in second red. So kind task steps there that run in a set order to perform logic that the task requires. So every task, again, runs as a pod on the Kubernetes cluster with each step running in its own container. So first here, I make this hello world YAML file task over there, which you see with that first arrow. It includes the small script that says, hello world. And next we create this task run, kind task run you can see there, and which instantiates and executes the task. So you can see that it runs, and then the output confirms, did it complete? Yes, it did. Cool. Next tool is
All right. So the next thing that we'll be talking about is Argo, and we'll actually specifically be talking about Argo CD. So the Argo project is a series of open source tools. They had kind of originated it into it and then got donated to the community. So there are various pieces. One, the CD for continuous delivery. And then there are some other things for like workflows, event management, rollouts, and so on. So we're going to be focusing specifically on the Argo CD side of things. And one of the big benefits of Argo, and it's one of the reasons why it's become very popular in the Kubernetes ecosystem, is that it was kind of built with this Kubernetes resource model in mind. So a lot of these other tools, like Jenkins, for example, has been sort of retrofitted, or I guess maybe not retrofitted, but like, future fitted to be able to adapt to having this sort of container and object and resource model. But Argo CD was built with that as sort of the core and native component. So essentially, it's taking principles such as everything really should be declarative, should be version controlled, your configs and everything should be defined and stored in your repo. And then also because of that, your lifecycle then becomes much more suited for automation, auditing, and it is sort of understandable because then you'll be able to take and read the definitions that you have in your source control and then match that to what you expect your state to be in your cluster. So you've got a variety of ways of being able to interact with Argo. There is kind of the API server, so you can connect with the API using the Argo command line tool as well, or also the user interface or the dashboard. But also, as you can see, there's a lot of integration with other tools, so you can take and use different tools and integrate that with Argo as well. So essentially, you can have this running directly inside your cluster. And what it'll do is just take and sort of monitor your code repo for changes. And as changes are committed to Git, basically Argo in your cluster will see those changes, and based on the definitions, we'll take and reconcile and pull that, either that image or those configs or those changes after the code is merged in, and put that into the cluster. So it might be running directly in the cluster, or there might be a separate management cluster then that takes care of making sure that all of your different clusters are up to date. So essentially, when we're looking at some of the key resources, and hooray, we've got more YAML here, you will have your application itself. So a definition of what your application is. Here we're using that. This is a sample based off of our demo repo, where you can see that you have the repository itself that is that stores the code. You can have an overall container definition of a project, which is essentially a group of applications. So you might have a team that's working on a specific project that has various applications that work together. And then at the base layer, you'll have the actual Kubernetes manifests that are going to define, the image and so on. And that can also be managed or will support customize, Helm, or just plain YAML. There is also the idea of things like app sets or app projects, and that's just as your hierarchy gets more complicated, you can have this sort of cascading definition of what you want an application or a collection of applications to look like. So the setup is essentially pretty straightforward, actually. You can just run there's the Helm chart for Argo. You can pretty much in a few commands have this up and running within your cluster to be able to start playing around and using it. So you have, your kubectl commands, and then the Argo CD command line tool is just Argo CD. Once you've got your credentials and auth set up, then essentially you can go in and list apps and so on. So that can also be plugged into your scripting or automation tools if you had the need to be able to do that.
And thank you, Muriel. And our last tool that we'll cover before we get into some demos is revisiting Jenkins. Again, this time Jenkins X. So Jenkins X launched in 2018, and it builds on the previous Jenkins automation server that we looked at, but it's specifically designed for modern cloud environments. And what does that really mean? The entire Jenkins X ecosystem revolves around Git. So it uses a cluster Git repository to manage your installations, extensions, and applications. And by default, Jenkins use Tecton, you got it. We said it earlier, for cloud native pipeline orchestration, but it can also work with traditional Jenkins pipelines for users with legacy workloads. So it incorporates a chat ops functionality, which allows developers to interact with their pipelines through comments on your pull requests. And it offers both the CLI JX and a GUI option for interacting with the system. And for every pull request, Jenkins X automatically creates a preview environment. So you can see the impact of your changes before merging them, which I think is pretty neat. Cool. Let's see a cool graph on how it works. Take a look at it. So the key concepts here are the source repositories, environments, and pipelines. So source repos are a Kubernetes custom resource, which creates your file structure and sets up your tools. Your environments like dev, staging, and prod in our Kubernetes custom resources in Jenkins X, where your application code lives. And then you'll see the pipelines. Where are they on here? Pipelines. Boop. Okay. So pipelines are made up. You see it over there? Okay, great. The pipelines made up of different steps, and a step can have 3 kinds: stage, preview, and promote. So using single command operations, you can create your Git repos, webhooks, and CI/CD CD pipelines. So here's some examples of the neat chat ops commands. I haven't tested all these, but I thought it was this is straight from their docs. I thought that was pretty cool. Yeah. And so finally, what kind of tool should I use, Muriel?
Elizabeth, it depends, which I think is sort of the generic answer that we get. It's I think our goal was not necessarily to be prescriptive, but really to provide an overview of some of the different things that are available in the ecosystem. Like often the tool in use may be dependent on the existing environment, like the existing tool chain, any specific versions or dependencies that might be in place. But also, as we kind of highlighted throughout, there are a lot of these that really integrate and interoperate with each other. So your decision if you are starting brand new and from scratch and deploying directly into, for example, a Kubernetes cluster that is local, the things that you might do might be very different than if you're working in a larger enterprise or with a different type of team. So we've got a bit of a summary here of the different tools that we went through for the continuous deployment or CD side of things. Argo, Tecton, Jenkins, and Jenkins X. So this is more of a takeaway for reference, but what is really interesting is just how some of these tools can work together. So essentially, when we're looking at interoperability, when you have your developer tool like Scaffold, you can do your deployments through this tool using things like kubectl, or you can do your deploy and render with Helm as the engine for that, or the rendering component using Kustomize. So essentially, Scaffold just gives you that developer framework for being able to do rapid dev and deployment. In Argo, when you're looking at Argo, once that's set up, the app delivery can be done using either customized Helm and YAML as the base for your actual YAML definitions of your application. Same thing on the Jenkins side of things. There's a plugin for Kubernetes, which is essentially using kubectl under the hood and kind of taking that command-based approach. And then also Jenkins X and Tecton, you heard a little bit about just the basis of that. And there is a pretty massive catalog of tasks as well. And then on the Helm side of things, like Helm kind of is the catch-all for all of it. There is a Helm chart for pretty much each one of these tools. So if you did want to use that to be able to deploy any of these CD tools, you can use Helm for that and do some of your management. And just keep in mind that there is sort of that templating model. So if you did want to do something like, let me do my base application installation using Helm, but then have customized overlays so that you can say, take this base, add on a piece if you're doing your dev environment, add on a separate piece if you're doing your staging, or add on a separate one if you're doing prod, then that's a pattern for being able to use these things together. So we do have some of these resources, which are also available in our demo repo. And we'll, I think Elizabeth mentioned, we'll figure out how to make sure this gets over to everybody as a takeaway. No, and I think this is.
Oh yeah, this
for you, for you and me.
Actual footage. Muriel and I met at KubeCon in 2023, and yeah, I just kept seeing her at all these different talks that I went to, and I had made it was the Taylor Swift Eras Tour time, so I made all these friendship bracelets that said KubeCon and was giving them out to people that I thought looked like they'd be interested. And Muriel had these really awesome earrings, and yeah, so we became really quick friends, and we went to a talk given by some other women developers, and we went up to chat after them, and they're like, you two should give a talk, and we were like, okay, ha 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 ha. And then we went ahead and did it. So yeah, that was us. And yeah, make time to meet other people here, because you never know who you're going to collaborate with or end up on stage with. Yes. So
so yeah, and I guess this is maybe a question on timing. Is we can expand and contract the demos we need. I'm not sure how long y'all are meeting for. I guess we can maybe multiple choice of, do folks want the demo? Do folks want a break and kind of get more time for chatting and conversation? Like Elizabeth, I'll let you feedback on that also, because we have a few different pathways. Or we can do a mini version of the demo.
Vibe check. I saw someone say demo. Demos. All right. That's great. Let us. This might take some configuration. Again, like I said, we haven't done this apart before, so we'll try. Muriel, it was like staring at a giant. I was like looking at a giant version of you on this screen.
Oh my God. Here, I think I need to rearrange my windows a little bit.
Oh, here's the Zoom. It's over here. Okay. Let me I'll just unplug here for a second so I can take a look at this. There we go.
Oh.
There we go.
All right. I don't know if does the demo window show up?
Plug you back in. Yes. Okay.
Okay.
Good.
Cool. Cool. Well, I will hand this over to Elizabeth, and I can drive. So
great. You'll be my hands. You'll be my hands.
I can't. I don't think I can see your hands.
Well, I can. How about I can talk through, and maybe you copy the commands and run them in your terminal. Does that work?
Yes. So okay. we can do that. And I'll do a quick note too as a takeaway. There is this demo for deploying a Spring Boot app to Kubernetes. So that is kind of a step-by-step walkthrough, and you could substitute the GKE Kubernetes engine for your existing clusters, such as Minikube and so on. So if you did want to have something that was very Java specific versus our fun and exciting Python example here, then that will be available as well.
Oh, that was such a good message about the Java app. Thank you. Yes. Okay. So a demo, the demo that we have here, we start with looking at Minikube, which is a fun thing. I don't know if anybody has experience working with Minikube, but that was like how I got started learning about Kubernetes. It's like you can run a local Kubernetes cluster on your machine. So it's easy to play around with and doesn't cost you any money. You're not putting anything out there. So, and given that this was an introductory beginner's talk, thought it would be nice to start at the beginning, especially. And I love like going to talks where people share about things that they just take and learn, and like the resources that we have to play around with at work or with other things to just share that out. Yeah, I think it's really cool. So, but this demo, or so introducing your Kubernetes cluster on Minikube. So you'll need to, oh, Muriel, you don't have Docker desktop, right?
I do not have Docker Desktop, but I do have Minikube running here. So I actually, just to save folks from wading through all of the background processes, I started up the Minikube cluster
Awesome.
beforehand. So it is running here locally.
Thank you. Yep. Well,
So,
can you make the terminal font a little bigger?
oh, yes.
Awesome. Yes. So it's up and started. So we'll see you ran your Minikube start. Great. And that's the command to get it running. And then you'll see Minikube cluster. It'll say that it is running. We see that it's running. Awesome. So the option that we'll go with for this is we'll just take the image and straight run it. So you'll remember that Muriel showed that at the beginning when we were going through the manual deploys. So this was one option. So this is showing how you can just take an image, the containerized image, and run it on your Kubernetes cluster, which is running on your laptop. Beep, 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 beep. Awesome. And ta-da! So let's try running Cube. Oh, there you she already has it. She can read the demo too. Thank you. We could do get pods. We could do describe pod. Where am I? Yep. Awesome. So this will give you a ton of information about what you have existing in your pod. Yeah, and yeah, so that's some information that you can get. I use that for debugging. It's going to be pretty verbose, but I think it's fun stuff sift through. Especially when I get a Java build error, it's nice. So let's see. So we have our Minikube cluster up. Let's talk about the customize. So in our Where Am I app folder, we have examples using customize to deploy overlays onto the K8s base layer. Yes. Let's take a look at some. We'll take a look at two. To get a sense of what our cluster looks like. Oh yeah, we did our kubectl describe pod. We just did that.
All right, sorry, I'm trying to match clicks with you while I bring up the customization here on the back end overlay.
Thank you. You're doing great. Thanks for driving over there. Yes. Okay.
All right, so let me see. I can pull up the we have our backend overlay, and then oh, here we go. We have our backend overlay example, and then also just the base deployment information.
Awesome. Awesome. Thank you. And let's take a look in the, can we take a look in the describe pod output? And can you scroll up a little bit? Or yeah, up. Great. So we see that's our image that we pulled. Okay, great. We have our container. Where am I? What else we got? Anything else that's interesting here to show you? Did that do something when I touched it, or was that you? That was you. Okay, great. Excellent. Cool. So that's all we have in here. So let's apply the where am I the Kate's backend overlay example, this kubectl apply command here.
Here we go.
I suppose the mystery is a bit gone since I have the output right there. But, you know, if you're at home and you're like, what did that look like? I don't remember. You'll know. Okay, it's supposed to create all these things. Da -da 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 -da. Great, it worked. So the config map, where am I backend, will have some new fields configured. And it overlays the base manifest with the following file. So the base manifest, you'll see that there's been changes, and it overlays it with this file here. So maybe a bit more concretely, we'll look at the describe pod again. We have some backends here now.
Okay, I'm just going to do this, which is for shortcuts.
Beautiful. Great. So you'll see we have all of this new information here with that's been enabled. Scroll up a little more. Excellent. So we have our where my backend. We've got a couple more in there. Cool. And
oh, sorry. So should we skip the front end?
Yeah.
We did the, but essentially it'll be the same thing where you now have the base and you can overlay all of these different, you know, like here are some examples using a gRPC front end versus a gRPC back end and so on, where the customizations for these different variants of the application now can just get overlaid off the same base, and you don't have to, you reduce the repetition, you know, so that you don't have, and it also reduces the number of places to modify because you have a common base. So essentially that is the pattern.
Great. Thank you.
Should I move on to Helm?
Yes, please.
Okay, so I will probably breeze through this pretty quickly. I am going to clear, so we set up, maybe see if I can increase this. So essentially, as mentioned, there is Artifact Hub, which currently has quite a few different Helm charts available. So if you do Helm search hub, essentially you're going to get a lot of stuff. So everything from Istio to Zot to, you know, some Zookeeper stuff. So if we wanted to do a search specifically for one of the tools we talked about, like Argo CD, we can do that. But also, as you can see, there are still quite a few different charts, some of them from the official project and some of them from other folks out there that have published these different charts. So now what we'll do is we'll add a specific repository. And so this will be the official Argo And if we do this Helm repo add, now you can see that it has been added to the repos, and we're going to do repo list. And you can see there's another repo that I added once upon a time, and then this Argo repo that we just selected. So now if we're doing a Helm search repo, we're getting a much shorter and saner list of the different charts that are available. So kind of the nice thing as well is that you are able to add in the ability to do some different searches based off of versions. If you wanted to get really fancy, you could do searches that use regex to be able to get and look for specific things, so that if you have this built into automation, you can now have certain, you can just kind of chain things to be able to enforce like what versions might map to different applications or different environments and so on. So they're just a lot more flexible in searching than the built-in default search of the hub. So you can also, in addition, install directly, as mentioned. So if you do something like Helm install, and we're going to do a Helm install of Where Am I Remote. Let me see if I can copy here. Oh, and so this is actually, I have something that is already in the namespace default. I'm actually gonna delete.
The last time live demo went totally smooth, so this is great. You get the live.
Oh yes, I know, because we went in and we can actually specify a separate namespace, but essentially we're just trying to deploy into the same namespace. So I want to go back and delete. What did we do? We didn't run. Okay. So I'm actually, just in the interests of time, going to skip this, but what we would do here is just delete the one, or like pass in a specific namespace to be able to install into that namespace. We can also run things like show values. And what that'll do is it'll show the different templated values that can be passed in. So you can see things that we can define, for example, like the number of replicas, where in development you might just want to have one, but in your other environments you might want to have multiple. And then same thing for the service. You might have something local to expose the port, and then have another load balancer or ingress or something like that if you're deploying into production. So you can see there's basically the ability to do installations of both the front end and the back end, and then being able to list in all namespaces. And so here, if we wanted to do the Helm status, let me see, actually, I might be able to do this, but let's see, where am I? Oh, Helm. Okay. I think we did this last time as well. Okay, sorry. So essentially, what we did here is just install into that specific namespace. So that basically now took that specific chart and installed that directly into another namespace. So you can go in and here, just do Helm list all namespaces, and then also Helm status. Where am I? Namespace Helm. And oh, I did not find the release. Oh, where am I? Remote. Okay, cool. So because that was the name was basically, we had that specific remote. And so now you can see, you can find all of the different applications here that are managed by Helm, including the revision, like various version information. And then you can see the status of that specific application, similar to a shorter version with like Helm specific metadata, similar to what we were doing when we did the kubectl describe. So this is kind of an example using Helm for being able to do that management, similar to what we did with the kubectl earlier. So the very final portion of it is now looking at scaffold. And essentially, I'll take a very quick look here at the scaffold.dev file or scaffold.yaml file. And you can see you've got some definitions here, like when you run scaffold dev, for example, and there are several things that you can do with scaffold, like rendering, building, deploying, and so on. But we'll look at just the dev, for example, right now, which is going to launch this sort of like interactive dev debug environment. But you can have a definition of what you want your build to look like. You can have different profiles. So if you have a local profile and then if you have a remote profile, different actions can happen. Here is the definition of the actual manifest. So you can see it's the where am I and then the service definition. Some port forwarding tools. So all of these things, including if we're using a Helm profile, where to be able to find that release information. So essentially all of this is defined so that there's kind of a consistent set of development parameters. And if you go in and just clone this repository to start making any feature updates, it's basically just going in and running, let me back up to the main thing, scaffold dev. And essentially it goes through and is missing a value. So I mean, this is the benefit of, the benefit and the peril of live demos is going through possible bombs. So essentially, I actually have this, which it worked in dev, but not in prod. But essentially, this was sort of like a previous run of scaffold dev, which, as you can see, went through the entire build process first. And then after the actual build, then the tagging happens, the deployment happens, and then from there, the port forwarding, so that now you've got kind of a live interactive development environment that you could then use to be able to interact with and see the application running. So that's kind of that as far as demo goes, and like be super open to questions, or if you wanted to watch us maybe do some live debug on why the last scaffold command didn't run, then we can do that as well. But I think that takes us to the end of everything, just before 7. So one, thank you all for being here and listening, and I'd love to hear any feedback or thoughts or questions. And over to you, Elizabeth. I think I do not have any audio on my side. Oh, there you are.
Can you hear him now?
Yes, I can.
Yes. Oh my gosh. Yeah, like at work? I can't tell you. Yeah. That's yes.
Adobe uses Argo CI/CD, Helm chart, Kubernetes. They use some forks of Kubernetes, like Red Hat, OpenShift, as well. Kind of business partnership based, partnership driven development. They also we used Argo workflows very, very heavily as well.
Oh, awesome.
Ian?
Oh, okay. No, I was just, so I know you guys have the repo, so I can definitely and obviously I know how to read documentation, but are there any other resources that you guys, because I'm new to CI/CD. I do.
Yeah, so we did include a doc with a few different resources here as well. Let me see. But they're kind of just links to some different tools directly. I think that's something we can maybe follow up with. There's the CD Foundation, the Continuous Delivery Foundation, which has some lists that go through just different DevOps approaches and principles and so on. There are also two channels on YouTube which are actually really great. One is DevOps Guy, or that DevOps Guy, and the other is, I think, DevOps World with Nana. And they have a great set of, I mean, I think they've got both intro and long form videos for each one of the tools that we've mentioned, for different principles, but also just some getting started stuff that talk about like fundamentals and concepts and getting started in different ways. So those are two channels that I feel like have some really great resources in addition to just some of the docs that are out there online, if that it helps as a starting point.
Copy of Employee with Joy.
Oh, I have stickers. Rats. I'll bring some for you.
I told you I need stickers.
Yeah. Ah. Yeah. Da-da-da-da. Muriel's the gray one. I'm the orange one. I know, for another a new talk. Yeah. Yeah. When we oh my gosh, we're like, everybody come we're gonna revisit Deploy with Joy. Yeah, I have a mentor when I was like, we were trying to get ready going through the RFP or the call for proposals process. And so when I was talking to somebody and he was like, just pick something you don't know anything about and then do some research on it, like something you want to know about. And yeah, so this space again is pretty new for me. Muriel is an expert, and I've been learning along the way, and yeah, we've had a lot of fun with it. Yeah.
I was gonna also link a couple things, which I'll send these over to Elizabeth and Bijou, and maybe can get circulated to the group, because there are some cool best practices guides from the Continuous Delivery Foundation, and then also there is a site dora.dev, which is from the DevOps Research Assessment project, and there's a lot of stuff there now around how Gen AI is integrating into software development, which is something we haven't even really touched on, and everybody's trying to figure out what it means right now. But there are some guides around what are some of the capabilities and some of the key principles around CI/CD, things that are just really important and relevant to that process, because they're kind of the three different components, right? There's the tools, which we talked about, but then there's also a lot that's just around the process and the people. So it's kind of like the people, process, tech of like how to be able to implement this in the context of a team workflow, and putting the right tools in the right place.
So if you went back to your talk and had the field of thought, you listed every name.
Uh-huh.
For people in this group or people in your audience, are there ones that are kind of gaining traction that you'd say these are the ones to pay attention to, some that are probably behind in a year? And I ask that only because, you know, I'm old enough to remember back in the day, there was about a dozen container orchestration platforms, and all of a sudden one whole, you know, Kubernetes did this and everyone else did that. Anybody who banked on these other like Docker Swarm and stuff are like, we're gonna have to pivot.
Yeah. I mean, I guess definitely on the container orchestration, if you like, you know, you've seen all the container orchestration wars, like you mentioned, with Docker Swarm and everything else, and Kubernetes has definitely been the line zone across the board. Although there have been some really interesting trends for some places that have kind of gone back and said like, hey, we deployed on Kubernetes and then kind of went back to doing a VM based thing because whatever it made sense for that specific use case. So there's kind of the one Kubernetes world of deployment, but also now more and more the ability to run like serverless containers if there's a use case where you're like, it's self-contained, I don't want to have to manage the infra of Kubernetes and just land there. But on the tooling side, from the ones that we've looked at, I think I heard someone mention that they'd been using, or their org was using Argo, and that's definitely been the hot one that's been gaining a lot of traction right now, because it's taken that kind of Kubernetes model, and it's been kind of friendly and integrated into that workflow. I think the one caveat for that is that if there are other existing applications in the ecosystem that aren't using Kubernetes, then you might have like these two sets of tools that you're managing, is the Kubernetes stuff with Argo and then the other tooling. And so that's why, you know, for as long as Jenkins has been around, it still is pretty sticky with folks, just because there have been so many pipelines and everything that have been really integrated and invested in that world for a while. And there's sort of this very long and slow evolution of how people are continuing to use Jenkins in different ways. So I don't know if that helped to, you know, just.
Is the play for Jenkins there to look at. We had some teams that were using it specifically for the commit comments, the git commit comments, to trigger things like spinning up a new environment specifically for testing.
Yeah, I didn't. I caught a little bit of that. Or what tool did you mention?
Jenkins X. We had a couple teams that were specifically using it. Your environment creation for branch testing.
Cool.
Yes, any other questions, or maybe favorite tools or approaches that folks, or maybe unfavorable tools that y'all are stuck with that you would wish you didn't have to use?
I've got a shout out to the Go templating that you showed on the screen that everybody hates. The worst part about language. We could fix that.
Oracle users are using Argo? Sorry.
Adobe.
Yes. Uh-huh. Uh-huh. It's a fork, right? Or Jenkins is a fork? Okay, maybe I don't want to say that in front of the crowd, but yeah.
There's some weird legal stuff going on when Oracle was trying to API definition is copyrightable.
Hmm.
And so the open source community split Hudson off. And then pick it from there. And monetize the Oracle branded Hudson, and of course it didn't work.
Cousins were fighting.
It was we don't talk about that time. We don't talk about Bruno here.